Garbage. What is it exactly that we throw away? The main thing we throw away is paper. One of the biggest disappointments, or if you want to call it, I don't know, of the computer revolution was believed that we were not going to have to use paper anymore. But guess what? People will always print backups, and there's so much more data that's out there because, or data that's available because of the computer revolution, that we actually print more paper than we used to. Or use more paper than we used to, I should say. The same thing was supposed to be true of time spent doing, things like accounting and things like that. But what did the computer revolution also did was it gave more data to access and do stuff with, so people don't spend any less time in the office consequently. So anyway, the heck with computers, but paper's number one. Then we have food waste, yard waste, plastic. And metal, wood, and glass. So volume's important, of course, but really when we look at the landfills and what's going to be in the landfills and how long it's going to be there, and also what it might produce while it's in there as far as toxic compounds and things like that, we have to look at decomposition. Now this decomposition is not just biological, we're talking about also the chemical decomposition, like with metals and things like that. So the first one we have here, glass, question mark. Why would that be? Why would glass have kind of an unknown decomposition rate?
Because it don't decompose.
Yeah, well, what's it made out of?
Sand.
Sand. Glass is fused sand, and consequently when it breaks down, it's just going to be smaller and smaller pieces. It's basically, the crystalline structure is different than when it is sand, but it is basically, going to be around as long as sand is around, and if you have a volcanic event or something like that, that'll melt it and get rid of it, but otherwise it's going to be around for many, many millennia. Plastics, some plastics decompose fairly rapidly. If you ever noticed, you ever had like the plastic grocery bags for a while around, and then you try to use one and it just completely rips? Yeah. They're kind of set to decompose. But there are other plastics, high density plastics, things like that could be around for 1,000 years. A lot of these we don't know. A lot of these are also dependent upon, particularly with plastics, because they're organic, whether or not there are bacteria that will adapt to consuming them. Because there are bacteria that consume plastics already. Some plastics not yet, but they may be, that may have to it because bacteria are very adaptable in that way. Metals, it's a matter of corrosion. These are for your common metals. Now some metals like gold will stay around for thousands and thousands of years simply because it's non-reactive. The one that decomposes the fastest, as you might imagine, is biomass, paper, wood, food waste, and fortunately those are the main things that we throw away. Yard waste also, those are the top three there. So they do decompose rather quickly, but it does require more than just piling them all into one spot. So we'll talk about how at the landfill they layer it in order to accelerate that particular process. So pretty much since people have been around as a species, we've been taking our garbage and moving it away to areas away from where we live. And other animals do that as well, of course. So it's not uncommon that we've had dumps for a long time where everybody in a society would take their garbage. They are simple, obviously. They do require a lot of land. The high-tech dumps that we call landfills now do have a lot of production costs associated with them, as well as maintenance and things that are there to guard against particular problems. The main one that they are concerned with, the biggest environmental problem as far as a direct threat to the environment, is your groundwater contamination. So that's the biggest environmental problem or threat associated with using a landfill. Now I will say this also, of course, you have, landfills got to take up space, so that's habitat alteration. The garbage has to be transported to the landfill, so that's anytime you transport anything, you have environmental impact there. But if you want to talk about a direct consequence of throwing stuff away, then your groundwater contamination is the major issue we have with landfills. And it's particularly because of this kind of stuff we throw away, things that we're not supposed to throw away, even by law, but make it into the garbage anyway. Perhaps not as long as people have been piling up garbage, but not much longer. Since people have been able to manipulate fire, we've been burning our garbage. It's an easy way to reduce the amount of material that's there, and it also has the potential for energy production. So there are garbage to, or waste to energy, they call it, incinerators that, if you burn something, you can boil water, you can run a steam turbine, you can generate electricity. So that's the principle that's behind that. But as you can imagine, it does have the potential to produce a lot of air pollution. They have to go through a lot of sorting. They have to separate most of the stuff out. Also, the ash that's left over after they burn at one of these incinerators is hazardous waste. So it has to be treated specially. So it has some limitations. It's one of those other things, kind of like nuclear power plants, where it would be a lot more common if they weren't such a major cost to start and run and things like that. They do produce a profit after a while because they produce electricity, but they're not perfect by any means. They have their environmental and practical drawbacks. Of course, the best thing is recycling. This means you're basically not throwing it away or disposing of it. You're using it again, obviously. There are many positives when it comes to recycling, besides just not taking up landfill space. As a matter of fact, if you weigh things out, that is the least of the benefits of recycling. The big benefits come in the fact that you don't have to, when it comes to metals and things like that, mine the materials, the raw materials, or acquire the raw materials. This is always a big bonus, of course, for things that you recycle. And also some of those things require processing and refinement, such as metals and oils tend to take a lot of energy and be polluting processes in themselves, producing their products from them. So all those are on the plus side of recycling. On the negative side, you do have some high costs associated both with the transportation and the sorting process. And unfortunately, a lot of the recycling process itself takes energy, it takes money to do so. That's why you see a lot of recycled products like plastic. Recycled plastic products are actually more expensive than virgin plastic products. So that's a point in technology that hopefully we're getting to where we can counter that, but it's still an expensive one. Now, metals, on the other hand, metals are the best thing to recycle, by the way. Metals are always less expensive to recycle than they are to produce from scratch. The priority, by the way, is reduce, reuse, recycle. Make sure you can remember those three in that order. Reduce just means, of course, you're using less of whatever product it is that might get thrown away. Reuse it, of course, means rather than throwing it away, you can reuse it again for some other purpose, like a water bottle being, well, that's not another purpose, but refilling your water bottle. You guys are all familiar with that. And then recycling's good, but it's kind of a last resort if you can't do the first two R's, is to recycle because of the transportation, separation, and the recycling process itself uses energy to do, and so therefore has some impact of its own. All right, modern landfills have certain things that they do to, well, I guess I'll take that group 7, but they weren't called landfills in the past, which is kind of how I'm trying to differentiate them, but it is still sort of. They're called dumps. Just a dump. Okay. Got to take a dump at the dump. So dumps of the past, which would just be a place where you dumped your garbage, where tend to be most people would dump it in one particular place. They, for one thing, are designed to accelerate. I didn't really leave room for this, did I? Decomposition. So, and protect the groundwater. And the way they do that, first of all, protecting groundwater, they use plastic and clay. They usually put down a layer of clay and then they'll put down a layer of plastic on top of it. And in case the plastic leaks, clay, as we mentioned before, is very good at absorbing water and holding it in place and keeping it from going through. The problem is something called leachate. I've got it in here somewhere. Well, that term is here somewhere, but yeah, we'll get to it. So leachate is just the water, precipitation water that soaks through. There it is. Yeah, that soaks through the garbage after it rains on it or after snow melts on it or whatever else. And of course, as it goes through, leaching means to soak stuff through like water does through coffee grounds. And if there's bad stuff in there, if there's toxic metals, if there's toxic petroleum products, things that are not going to decompose, then that leachate can take that with it. And of course, the problem is if that gets in the groundwater, then the groundwater is contaminated, and groundwater is, of course, oftentimes a drinking water supply. So that has been, there have been cases where they've traced groundwater contamination to landfills, and consequently modern landfills, they'll always put down a type of a liner to reduce it. It's just a heavy plastic, kind of like a thick garbage bag almost, that they put out thousands of acres of, depending on how big the landfill is. Like I said, they'll usually put a layer of clay underneath that also, because if that liner leaks, then the clay will typically absorb it. The speeding up of the decomposition process is a relatively simple thing. All they do after they put down a layer of waste, usually on a daily basis, the tractors will come through and they'll put down a layer of soil. So what is it in soil that's going to help the garbage decompose faster? Well, there might be some worms in there. Bacteria more so. Bacteria and funguses. Your decomposers are mainly in their soil, so this helps the decomposition process. So that's a big thing. They actually learned that in the war, apparently, where you would, if you're out on maneuvers and actual wartime situation, you have garbage, you got to bury it, and they found that a day or so it was pretty much gone. Their food waste and stuff like that, because the extra soil decomposition made it go faster. Another issue, this is more of a practical thing, well, it's an environmental thing when we talk about greenhouse gases, which we haven't talked about yet, but most of your landfills will have a methane collection system. And methane is produced by bacteria through any kind of decomposition process. They also tend to collect this at wastewater treatment facilities. It's a common byproduct of anaerobic metabolism. And it is, sometimes they collect it, sometimes they burn it off. The reason why you would burn it is maybe you don't have a need for it. I don't know why they can't find a practical need for it. But the methane is a more powerful greenhouse gas than carbon dioxide. So when you burn the methane, it'll become carbon dioxide. And of course, carbon dioxide is also a greenhouse gas, but it's not anywhere near as powerful a greenhouse gas as methane. So, but the good thing is, the best thing you can do if you can is just to collect the methane, and then you can burn it in trucks and on the side of the facility or whatever else you need a fuel for, because you can run a internal combustion engine pretty easily off of that. And also, you want to have a groundwater monitoring system. So you put down a liner to protect it, but liners can leak, so you want to make sure you have wells. They go into the aquifer, monitoring wells that go into the aquifer around the facility, and test it on a regular basis to see if any kind of nasty stuff, hazardous materials have leaked out. Okay? Any questions so far? Landfill design, different ways to deal with garbage. All right, well, let's talk about hazmats, hazardous materials, real quickly. These are things that are either too poisonous. I'll give you that one. Technically it's toxic.
Well, then why was the space so big?
Good question. Just to throw you guys off. It should be tricky, but like I said, I'll give you the point for it. Pretty much the same thing. Ignited, corrosive, or reactive. Basically, too dangerous to just have hanging, sitting around in a landfill. With people, of course, are working there and things like that. So that would not be good. And also, if you notice this with the methane, there have been many in the past infamous, and particularly it's still a problem in a lot of developing nations, of landfill fires, because they build up the methane and they catch on fire, and particularly if you got some really flammable stuff in there, it's a bad thing if you've got a garbage dump that's on fire near you. So some of the things that we can do with these things that are just too toxic just to throw away, or too hazardous just to throw away, is if they're really bad, like nuclear waste, for example, you can just isolate it. You can put it in something such as concrete. Sometimes they use glass as well. Glass is very impervious to thick glasses to radiation, and then you just got to store it and keep an eye on it for a while. This is, of course, as we've mentioned with nuclear energy, this is what's going on with nuclear waste around the world right now. It's just kind of sitting around, hoping nobody does anything with it. If it's a chemical hazard, and you have that chemical has a negative to it, or something that will neutralize it, like an acid and a base. You can do that, of course. That will help to make it less of a problem. A lot of your organic materials, although just simple burning is not a good idea, because the vapors of them could come out under a controlled furnace where you make sure it's sealed up for the most part. You're injecting oxygen into high temperatures. Pretty much any organic substance will break down into carbon dioxide and water. And then your other stuff, your ash, will come out, and then you have to treat the ash as hazardous material, but you can get rid of a lot of stuff just by making sure It's incinerated at high temperature. And then using organisms to do it. One of the main things that is used to deal with hazardous waste, such as oil spills, is bioremediation. As I mentioned earlier, bacteria have this interesting property to be able to mutate and adapt to consuming almost anything that's organic, including stuff that's not natural, that's organic, like plastics and petroleum products and things like that. And therefore, it's not uncommon if you have an oil spill, either in the water or on land, to put your bacteria out there, and they gobble it up. And a lot of times they're engineered bacteria, so that when they have finished eating whatever the hazardous material it is, they're engineered to only be able to live off of that, so they die off because they don't have any food left. So that uses bacteria, and sometimes they'll just chemically do it by using the enzymes that the bacteria use as well to break the chemicals down. And then phytoremediation. Phyto means what? In science speak? Plant. You're thinking photo. Phyto. Phyto with a Y. Sorry about that. So phyto means plant, and if you, that's using plants.
Phytoplankton.
And the thing about plants is that they're very good at absorbing stuff, as you might imagine, and they can actually take a fair amount of toxic stuff into their systems without it killing them. Many plants, different plants have differing levels of tolerance. But if you've got, say, a wetland area where a tanker or something, cracked open and leaked out all its stuff into the swamp and things like that, you can plant a bunch of these plants in there. Now, what you have to do is you have to harvest them afterwards, and then the plants themselves are treated like toxic waste. But it does take that toxin out of the system, and it's a pretty convenient way to do it as well. So that can be used to take toxins out of the soil and out of the water. Hyacinths, you ever seen the floating hyacinths, water hyacinths, and they got a purple flower, pretty, etc. Those are often used for removing both waste and excess nutrients, because you can float them out there. They rapidly multiply, and then you just harvest them on this big floating kind of, I wouldn't call it a boat really, but it just kind of harvests them up, and you take them off. And like I said, treat them as hazardous waste, depending upon what they have absorbed. If it's just nutrients, you can feed them to cows. Any questions?